Question. Explain Go's zero-value system. What are the zero values for each of Go's basic types, and why did the language designers choose this approach? Every type in Go has a defined zero value. When memory is allocated to store a value, either through a declaration or a call of make or new, and no explicit initialization is provided, the memory is given a default initialization. Each element of such a value is set to the zero value for its type: false for booleans, 0 for integers, 0.0 for floats, empty strings, and nil for pointers, functions, interfaces, slices, channels, and maps. This initialization is done recursively. So, for instance, each element of an array of structs will have its fields 0 if no value is specified. This eliminates undefined behavior common in C++. The zero-value philosophy simplifies code and enhances safety. Question. What is the zero value of an array versus a slice? Arrays are initialized with 0 values for each element. Slices are nil. Nil slice versus empty slice in Go. A nil slice is functionally equivalent to an empty slice for reading and appending. Calls to len, cap, and append work. Nil map versus empty map in Go. A nil map is safe to read from, returns 0 value of value type, but panics if you try to write to it. Question. Given this struct, what is its 0 value? Walk me through each field. Expected answer would be this. Is this struct ready to use? What problems might arise? Port 0 might not be invalid for your use case. Writing to a nil map panics. Calling methods on a nil logger panics. 0 duration might mean no timeout or instant timeout, depending on implementation. Question. What is the technical difference between new int and var_v? var_v allocates storage for an int, initializes it to 0, and names it v. New int allocates storage for an int, initializes it to 0, and returns a pointer to it. They both result in zero-value initialization. New is rarely used in modern Go. Question. Explain the difference between new t and make t with respect to 0 values and initialization. In Go, new and make serve different purposes. Calling new allocates storage for a new 0-valued value and returns its address. As noted earlier, fields will be 0 initialized. The result of new is always a pointer. In contrast, make is used only for slices, maps, and channels. It allocates and initializes the underlying data structure, returning the non-pointer value of that type. Question. Go's documentation emphasizes make the 0 value useful. Can you give examples of standard library types that embody this principle and one that does not? Some examples of 0 values are mutex, buffer, and wait group. Not immediately usable examples, HTTP client 0 value works but is not optimal. Regular expression cannot use 0 value. Question. In many languages, calling a method on a null object causes a crash. How does Go handle this? Write a snippet showing a safe method call on a nil pointer. A nil receiver occurs when you call a method on a pointer type, but the pointer itself is nil. Surprisingly, this is valid in Go and does not cause a panic. Go allows methods to be called on nil receivers. The receiver variable inside the method simply holds nil. Question. What happens when you call a method on a nil receiver? Does this differ between pointer and value receivers? Increment pointer panics. Nil pointer dereference when accessing c.value. Increment val panics. Go attempts to dereference to get the value. A nil pointer receiver does not automatically fail, only when you dereference it.
Question. What's the difference between these three declarations? Critical insight. JSON.Marshall returns null for nil slices, but square brackets for empty slices. This matters for API contracts. Question. Explain how Go uses 0 values in the "OK" idiom. When is it important to distinguish between value exists and is 0 versus value doesn't exist. These both return zero values, but for different reasons. The OK idiom is used to distinguish between a value that exists and is zero and a value that does not exist. Follow-up. Show other places where OK appears with zero values. Question. Explain the nuance between a nil interface and an interface holding a nil concrete value. An interface has two components, type and value. One is nil only when both are nil. An interface holding a nil concrete value is not nil because it still contains type information. This often trips people up. Another example, returning a nil concrete value as an interface still produces a non-nil interface because the interface remembers the concrete type. Question. How do embedded fields affect zero values and what gotchas exist? Key insight. Embedding a struct by value promotes a useful zero value. Embedding a pointer requires nil checking. Question. How would you implement a generic IsZero function and what are its limitations? Discussion. When would you use this in production? Validation, ORM operations, JSON, omitempty logic. Reflection-based approaches are slower than direct comparison. Use simple zero checks for comparable types when possible. Question. In Go's encoding/JSON, what does omitempty mean? Explain exactly which values are considered empty and show cases where developers expect a field to be omitted, but it is not. Omitempty tells the JSON encoder to exclude a struct field from the output if its value is the type's zero value. Omitempty checks nil, not length. Struct fields are never omitted. Why is omitempty often insufficient for APIs or databases? And how do you correctly represent field not provided versus provided with zero value? Because omitempty cannot distinguish intent, field absent or provided as zero. Omitempty checks the interface itself, not its content. Omitempty is fine for output optimization, but never sufficient for input validation or partial updates. Correct solution: use pointers. Question. How does the functional options pattern leverage zero values to create flexible APIs? Implement a server constructor using this pattern. Why is this better than a constructor with many parameters or a config struct? Zero values are overridden with defaults, then options are applied. This allows sensible defaults while keeping APIs flexible and extensible.